Welcome to Summarize Science, where we break down the latest breakthroughs in technology. Today, we are looking at a new way for computers to create and edit images more realistically than ever before. Researchers have developed a system called the Representation-Pivoted AutoEncoder, or RPiAE for short. Most modern AI tools use something called diffusion models, which work in a compressed digital space to save memory and time. However, there is often a trade-off. If the space is too compressed, the AI loses the fine details needed for editing. If the space is too complex, the AI has a hard time generating new images from scratch. The RPiAE model aims to provide the best of both worlds by acting as a high-quality bridge between pixels and data. They designed this tokenizer to preserve strong semantic meaning while still capturing tiny textures. This makes it much easier for the AI to handle both creative tasks and precise modifications. One of the biggest innovations in this paper is a strategy called representation-pivot regularization. This keeps a frozen pivot version of the encoder as a reference during training. By doing this, the researchers ensured the AI can learn to reconstruct fine details without drifting away from the core structure it needs to function. The system uses a variational bridge to squeeze high-dimensional features into a more compact format. This compact format is specifically designed to be diffusion-friendly, meaning the AI can navigate it easily to generate new art. Essentially, it cleans up the data so the generation process is smoother and more efficient. To get these results, the researchers used a three-stage training strategy. They first taught the model to be stable, then they focused on the data compression, and finally, they specialized the output for maximum quality. This step-by-step approach prevents the model from getting confused by competing goals. In these visual comparisons, you can see the difference that this new method makes. When asked to generate a purple bear or a specific bedroom setup, the RPiAE model produces much sharper and more coherent images. The details in the fur and the lighting on the objects are significantly more lifelike than older versions. Look at these examples of reconstruction, where the AI is tasked with recreating a real photo. The RPiAE model captures regular geometric patterns like wall tiles and mesh grids perfectly. Older models often failed to recover these structural details, leading to blurry or distorted textures. Editing is perhaps the most impressive part of this new technology. They show that you can change the color of a goat to yellow or swap a background to high mountains with incredible precision. Because the model understands the original image so well, the new edits blend in seamlessly without any weird digital artifacts. The data proves that this isn't just a visual improvement, as the model consistently hits the highest scores in technical benchmarks. It achieves the best reconstruction fidelity among all similar representation-based tokenizers currently available. In summary, the researchers have found a way to bridge the gap between creative generation and accurate image editing. By using a clever pivot system and a three-stage training plan, they've made AI tools both more powerful and easier to use. In the future, this could mean that professional-grade photo editing could be done by anyone with just a simple text command. Thanks for watching Summarize Science, and we will see you in the next breakthrough.